Syndeia, the MBSE integration platform from Intercax, offers a means to both build a digital thread, a federation of diverse models, and to analyze it, enabling both developers and program managers to do their work more efficiently. This video will focus on the analysis under two scenarios. In the first, we will look at a single model element, its contents and its connections, interactively. In the second, we will query the entire thread for real-time reports of connection status and project progress. We begin with the digital thread already built according to this schema. The workflow began with a collection of stakeholder requirements and translation to subsystem technical requirements, all within a JAMA Connect repository. JAMA also manages the intramodel relates linkage between each subsystem requirement and the stakeholder requirement or requirements it traces to. Through Syndeia, a subsystem requirement in JAMA may be linked to an activity in a SysML model managed in Teamwork Cloud, which carries out that function. In turn, the SysML element may be linked to a GitLab file, which contains the software code carrying out that function, a TestRail test case, which will test that function, and a Jira task, which will log status and other project management info related to that function. The digital thread is sustained by Syndeia Cloud, the server-based component of the integration platform. Syndeia Cloud maintains the intermodal connections between repositories in a configuration-managed graph database, and can also access the contents of the linked repositories, such as JAMA, Jira, Teamwork Cloud, and others, directly through their APIs. The user accesses Syndeia Cloud through its own REST API from their local web browser. Now, the structure of a digital thread should be designed to meet an organization's needs. The one shown here is simply provided as an example. The contents of our example are based on environmental issues in a shipboard setting, and they don't represent any actual or planned system. Under Scenario 1, I am a project manager for the shipboard environmental systems, and I want to check progress on meeting the sewage or black water treatment requirement. From the Syndeia web dashboard, I select the JAMA repository in which these requirements are held and display the contents which Syndeia Cloud extracts from that repository and shows in the Syndeia web dashboard. Given the complexity of the contents, I will use the dashboard search function to find a requirement containing the text Blackwater. In Graph View, I can expand the node representing the requirement to see its nearest neighbors in the digital thread, which include a JAMA set named ESOH Subsystem Requirements. This set contains the Blackwater control requirement, the JAMA Stakeholder Requirement Annex 4 Sewage, which is related to Blackwater control, and Teamwork Cloud SysML Activity Blackwater Systems Control, where an intermodal connection to the JAMA requirement had been created earlier through Syndeia. Now, the Syndeia graph does not contain or display all the system data for each JAMA requirement, but I can launch the JAMA web dashboard from the nodes in the diagram and view the data, assuming that I have access credentials for that repository. Here I have opened the stakeholder requirement Annex 4 Sewage. I can't do the same with the Teamwork Cloud element because I don't have a Teamwork Cloud web viewer available, but I can expand that node and display a further chain of connections to a Jira task, a GitHub file, and a TestRail test case. As with the JAMA requirement earlier, I can right-click on the test case and launch the TestRail web interface, again assuming that I have access to that repository. Here I can explore any test results available for this test case, as well as the structure of the test suite. If I expand the Jira issue ME-8 node, we see that it has an additional linkage to another Jira issue, ME2, and also that ME8 shows a dashed outline. The dashed outline indicates that it is a merged node. In other words, it represents a combination of different versions or timestamps of the same issue. The version of ME8 that the Teamwork Cloud element is connected to is not the same version that Jira task ME2 is connected to. As before, we can right-click on ME8 and open the Jira web browser to see the current contents. Each new comment or status change creates a new version of the Jira issue. We will want to evaluate how the changes impact the Connect elements, such as the Teamwork Cloud activity, before we use Syndeia to update the relation between Teamwork Cloud and Jira. Under Scenario 2, I want to check overall progress in constructing the digital thread, including the building of models and their linkage back to other models. We can use the powerful Gremlin Query language with the Syndeia Graph database for real-time reports on the connections between the federated models. An early step in our MBSE workflow links the subsystem requirements in JAMA to the SysML architecture elements. A simple Gremlin query can show all current connections, from JAMA requirements to SysML activities, within the Syndeia Maritime ESOH project. The network graph shows the JAMA nodes, in orange, connected to Teamwork Cloud nodes, in purple, 11 in total. As in the Digital Thread Explorer demonstrated earlier, the nodes can serve as entry point to the model element in a web viewer for that repository. In many cases, this information may be more useful in a tabular format. The power and flexibility of the graph analysis allows us to look for extended chains of connection between nearest neighbors. A different Gremlin query looks for the pattern JAMA requirement to Teamwork Cloud activity to GitLab file. A second set of connections is shown to the gold GitLab nodes. However, there are only 6 connections here, versus the 11 total between JAMA and Teamwork Cloud seen earlier. An alternate approach, using management by exception, asks for the Teamwork Cloud SysML activities that are connected to JAMA, but not GitLab. And here we can see a list of such artifacts in the tabular view. In each case, the Gremlin query results can be viewed or exported as a network diagram, a table, or in JSON structured data format. In this video, we have demonstrated the internal reporting capabilities of Syndeia Cloud through the Syndeia web dashboard. However, the philosophy behind Syndeia is that all the system data within the digital thread should be easily accessible through calls to the Syndeia Cloud REST API and available to customer-written and third-party visualization and documentation applications. Look for future videos demonstrating these capabilities, or contact us directly to learn more.